Yesterday we talked about proofs. So proofs, once again, were sort of, you were given some situation and you were asked to give examples or give reasons on why that is true and like how you came up with that conclusion. So this isn't necessarily a proof, but this is just sort of get us back in that parallel lines mindset. Cool, let's take your feet off, please. So I know lines blank and blank are parallel or not parallel because, so do we see any lines that we think are parallel up here?
Parallel.
A and B.
I didn't see the view.
Okay. Why do we think they're parallel?
Because they each have a 120-degree angle.
Alright, what do we call those types of angles? They are congruent, but what type of angle pair do they make? Alternate interior, because A and alternate. So in order to prove parallel lines, we always need one of those angle pairs, at least one of those angle pairs. Alternate interior, alternate exterior, corresponding consecutive. Those are your end goals. You need to find one of those. Once you find one of those, you can say these lines are parallel because whatever this reason was. But we always need to find one of those. Is there another way you could have solved this? What are these two? What do you call those? Corresponding, you could also say they have corresponding angles, and that would be enough to prove the parallel. Once again, the only time we ever get these angles happening, the only time they're ever equal like that, is if those lines are parallel. If those lines are a little bit off, those angles won't be equal. So as soon as we get parallel lines, we know we have those equal congruent sides or those supplementary angles, and that proves our lines are parallel. So last week, we talked about when you were given a set of parallel lines, you had to sort of find these parallel angles. When you have parallel lines, this implies that we have parallel angle pairs. This week, we're sort of doing the opposite. We're talking about the converse. So the converse is sort of the backwards or the flip version. Rather than doing parallel lines imply parallel angles, whenever we find parallel angles, this implies we have parallel lines. So by knowing we have parallel angles, we can prove that two lines are congruent, or two lines are parallel. And so we call these converse statements. So corresponding angles converse would be, I have corresponding angles here, so I can use a corresponding angle converse to prove those two lines are parallel. If I were to see consecutive angles, I could use a consecutive angle converse to prove I have parallel lines. Alternate interior angle converse, alternate exterior angle converse. So that's how, as soon as we find one of these parallel angles, we can automatically assume our lines are parallel. Thing is, if we find that we don't have parallel angles, that means we automatically don't have parallel lines. So this is our way of proving whether our lines are parallel or not. I'm sorry. So that's a way of proving whether our lines are parallel or not, by looking for one of these. Also, on your state test, when they do their two-column proofs, they'll like give you a lot of information, but they'll leave in blanks, and they'll have like all these little bubbles that you can like click and drag and put them into the spots to fill them in. They'll look like these. They'll say like corresponding angle converse. So we need to know what these names are to be able to recognize what that means. So if it says like proof A line A and B is congruent, you could say corresponding angle converse is that, or something. It will confuse it. So once again, with proofs, we're always going to be given a little bit of information to start with. We're going to be asked to show something, so asked to prove something. And then we're going to set up a two-column proof. So on our left column, it's going to be our statements. What are we saying? On our right column, it's going to be the reasons. What is the facts behind that? Why is that statement true? So the first thing we always want to put down for these is our given information. So what were we told straight up? So I was told, good, angle 4 and 5 are congruent. Once again, that little squiggly equal sign, that means congruence. Grab the equal sign with the squiggly over it. So angle 4 and 5 are congruent. That means they're the same angle.
Okay.
where it's two squiggly lines, that means approximate. But if it's an equals with a squiggly line over it, that means congruent. Right? All right, the reasoning behind this was given information. We were told that. So we just put, yeah, just put given, and that's enough. Okay, so we were given some information. We're asked to prove this. This is where we need to end up. We need to end up with T and X being, or T and X being parallel to each other. Once again, the reason we need to show, or the reason we show, or the way we show things are parallel, is by using one of those four angle pairs. We have to find one of those four angle pairs. As soon as we find that, then we can jump into these two angle pairs. All right, so we know 4 and 5 are congruent. That's where we start. Based off their location, we can say that 4 and 5 are 4 and 5. These are alternate interior angles. Our reasoning behind that is based off their location on the map and because they're congruent to each other. Alternate interior angles have to be congruent. And so because these ones are congruent, that means we have parallel lines. Open. You have your equations. You have your slope. Remember, we need the equation as well.
At this time, I need the homecoming court to report to the STEM CC.
That's what you did on the last one. We need the y-intercept and equation as well. Okay, so we have alternate interior angles. Once again, as soon as we end up with one of these angle pairs, we can jump straight to my two will end up pair. So I can jump straight to T is congruent to X, and the reasoning behind that is through my alternate interior angle converse. So we just use whatever converse statement of whatever angle pair we have. So I have alternate interior angles, so that's my converse statement. So on this first one, it was pretty easy because you can just sort of see like, oh, if those two are equal to, then they're alternate interior angles. The main practice that we need to do with him is just being able to write down those steps, being able to write down every single thought process that we go through, and make sure we don't miss anything. We use all the information that's given to us. Are we okay with this? All right. So we have angle 3 is 120 degrees. Angle 4 is 60 degrees. We need to prove that A is parallel to B. So once again, I'm going to start off with my given information. Angle 3 is 120. Angle 4 is 60. And that's given. All right, so we have our given information. So now that we have this information, we need to use this. We need to implement this in some way in order to be able to solve and prove that these two lines are parallel. So 120 degrees and 60 degrees. How can we use that information?
They add up to 180.
Okay, they add up to 180. So when we have two angles that add up to 180, what do we call that?
Supplementary.
Supplementary. So angle 3 and angle 4 are supplementary. And the reasoning behind that is because 120 degrees plus 160 degrees equals 180 degrees. Good. All right, so we now know 3 and 4 are supplementary. That's some solid piece of information right there. Based off of that, what can that tell us?
That those angles are consecutive.
Consecutive. So angle 3 and angle 4 are consecutive up there, and the reasoning is because angle 4 and angle 3 are supplementary. So once again, you're typically bouncing off information that you use in that last statement. That last statement is typically the reasoning. It's not always, but it's very often the reasoning behind your next statement. So we had 120 and 60. We use that to show they're supplementary. We had the fact that they're supplementary. We showed that to use that they're consecutive. We ended up with consecutive angles. What does that mean about our lines? What's our angle? To prove a parallel. If we get an angle pair, that's like our finishing statement that we get parallel lines. So all we have to do is A is parallel to B, reasoning because we have consecutive angles. So we can say the consecutive angle converse or consecutive converse. Whatever we want to use there. So once again, we're always looking for one of those angle pairs. As soon as you write down that angle pair, you can jump straight to, I know these two lines are parallel because whatever angle pair converse. The same word, but no. So consecutive is the type of angle pair we have. So these are consecutive angles. Converse, our converse statements are whenever we're using one of these angle pairs to prove something, prove parallel lines, that's a converse statement. We're working backwards. Typically, parallel lines imply parallel angles. Well, now we're saying parallel angles imply parallel lines. So we're doing the backwards of what we did last week. So it's a converse.
So like if we get full credit, if we just put down converse.
I would want you to put down both of them, so consecutive converse. I want you to put down what angle pair you used and then the converse stuff. Are we okay with that? Are we okay with all the steps we took on this one and how we sort of built off of that previous information that we have? Do you want to try this one on your own, or do you want to go through it together? Keep it rolling together?
Yeah.
Okay. So what's the first thing we always write down?
Given information.
Given information. So 2 and 7 are supplementary. The reason is that's given.
One of the first statement is always being not given.
Yeah, your first statement should always be your given information. That should always be where you start off with. Your last statement should always be what your proof is, what we're trying to prove. So this is basically saying this is where you start, this is where you need to end. All the stuff in the middle, that's what we have to figure out. All right, so looking at 2 and 7, do we have an angle pair that relates 2 and 7 together?
No.
No, so we don't have anything that puts 2 and 7 together by itself. So as of this moment, we don't have enough information to prove that they're parallel. So we're going to have to work a little bit. We're going to have to do some digging to be able to figure out what we can do to show that they're parallel. Now, what I typically think when I look at these is I look at how much information I'm given and how much information I've used so far. So far we've only used this given information. What other information on our picture, though, do we notice? We have these consecutive angles 4 and 6, right? All right, so I haven't used that information yet. So basically, typically when you're using a proof, you need to use all pieces of information that you're given, or all pieces of information that we see. So we've used this, or we kind of have this so far, but we haven't used 4 and 6 yet. So we need to think, how can I relate this stuff to 4 and 6, or how can I bring 4 and 6 into my? But how do I know 4 and 6 are supplementary? If I can show that they're consecutive, and if I can, or I can show they're consecutive, then I can show I have parallel lines. But in order to show they're consecutive, I need to show 4 and 6 are supplementary. So that's where we need to end up. How can I show 4 and 6 are supplementary? What do we see? What was that? 2 and 4 are vertical. Vertical angles, are they? They're going to be congruent. So 2 and 4 will be congruent, and the reason because they're vertical angles. Okay. So now I know if 2 and 7 are supplementary, what does that mean about 2 and 4, or 7 and 4? They're supplementary as well, because 2 is the same thing as 4. So I can basically take this 4, put it in for that. But do we have any connections that bring us 7 and 4 together? Do we have any angle pairs for that? It's still not enough. Can we bring in the 6 somehow? 7 and 6 are vertical as well. So I could say angle 7 is congruent to angle 6 because these are vertical angles. Okay. Now we're getting somewhere. So 2 is the same as 4. 7 is the same as 6. If 2 is supplementary to 7, then what does that mean about 6 and 4? They're supplementary as well. Because they're both the same as 2 and 7. So if 2 and 7 are supplementary, that means 6 and 4 have to be supplementary. Because 2 is the same as 4, 6 is the same as 7. So we can say angle 4 and angle 6 are supplementary. And the reasoning behind that is because angle 2 and angle 7 are supplementary. And 2 is the same as 4, 6 is the same as 7, so you're basically just replacing those angles. All right, we have 4 and 6 supplementary. Why were we trying to get here again?
Correlate them with the 2 and 4, like
What type of angle pair did we say 4 and 6 made?
consecutive.
Consecutive. So because they're supplementary, we know angle 4 and angle 6 are consecutive. And so that means, and the reasoning behind that is because angle 4 and angle 6 are supplementary. So once again, we're typically building off of that previous information, that previous statement you have. All right, we have consecutive angles. So that means we have an angle pair. So we can finish it up. One last statement. What should our final statement be? A is parallel to B. And the reasoning, because they're consecutive, so one of the biggest challenges is looking at the picture and looking at the information you're told and figuring out how can I relate all of this stuff together to end up with this statement. And how can I remember, like, what am I supposed to say? What is the next step? How can I build off of this previous information? Or how can I relate these two together to end up with this goal? The main thing is it just takes a lot of practice. You just have to keep working with it. And the more you do it, the more you work with it, the easier it becomes to sort of recognize those relationships and recognize, okay, this is where I need to end up, how can I get there? But just like working with a formula, it's something in practice. It's also you're thinking in a different way. Rather than thinking, okay, I did step A, now I need to do step B, now I need to do step C, now I need to do step E, like formula, rather than having that same rigorous steps every single time, this is much different. It's more abstract. You have to think outside the box. You have to think, okay, how can I relate all these different pieces of information? It's not going to be the same 6 steps every time. There are things that are consistent, but it's a different way of thinking, it's a different style. It's not just a formula. And so that's where I think most students struggle with proofs, is just because it's different from the other math they've done before. It's a different way of thinking about it. It's not as linear. It's not as straightforward, but it involves a lot of logic too. But we'll keep practicing. We'll keep working with it. We'll keep working on it. Oh, this one. This is the one where they're not together. I don't know. All right. So there's 2 here. We're going to focus on this first one. Yeah. So our goal is to prove A and B are parallel. So you'll have your statements. You'll have your reasons. Where would you start? Okay, so we see, so I'm going to say So we have 90 degrees and 90 degrees, and that's given information on that. Okay. Can we do anything to relate those two 90 degrees together? They are supplementary.
I thought we were
What?
just looking at it.
So, one. Is that okay? Because 90 degrees, both of these angles fall on both A and B, so you can use any sort of combination of them. And it's possible to prove them using this angle. It's also possible to prove them using this line.
They said they follow.
Well, I don't know. We haven't proved it yet.
I don't think they are.
You don't think A and B are parallel? Okay. Well, we're asked to prove it, so let's try. Alright, so we have these two 90 degrees that we see from the picture. We don't have an angle pair that relates these two directly, though. So we don't have an angle pair that relates this area or this location with this location. There's nothing that relates these two. None are consecutive, corresponding, alternate exterior, alternate interior. So we're going to have to move some things around. We're going to have to move some information around. So they're corresponding, but are they the same? So what does that mean about D and C? They're not parallel. That was the second part that we scratched out. We don't have- So basically, just forget this part for a moment. I should make this not a problem. We're just going to forget that line. Just focus on this.
So we have about 89 on there.
What was that?
We are 91, 89 on
Don't worry about 91. Don't worry about line.
Yeah, sure.
Okay. We're trying to figure out how can I relate this 90 degrees, this 90 degrees. How can I move that information around to sort of make one of those angle pairs appear? What was that? If it was down here, then it would be alternate exterior. So this is 90 degrees. It's a right angle. What does that mean about the angle measure of this? It's 90 degrees as well because this is a supplementary pair. So we could say, I should put whatever. So that bottom angle, I'm going to call this angle 3 for whatever reason. Angle 3 is also 90 degrees. Our reason is because angle 2 and angle 3 are supplementary. So because they form a line, we know they're going to be supplementary with each other. If one's 90 degrees, then through our supplementary thing, we figure out the other needs to be 90 degrees as well. Because 180 minus 9. Okay. So we now have that angle 3 is 90 degrees. Why did I want that in there?
Alternate exterior.
Okay. So angle 1 and angle 3 are alternate exterior angles. The reason is because angle 1 is congruent to angle 3. We saw they were both 90 degrees. Okay, so I have alternate exterior angles. What does that mean?